So this is for to the three.js. When I came here, I was like, oh my God, I'm just going to fill this with bits. So I'm super happy to be in this stage. So as Andrea said, I'm Soledad Penadés. I am working at Mozilla by day. So I'm an apps engineer, make apps, help people make apps. But by night, I'm super solid. So that's when I get to make noises and like blow up my neighbors. So what we're going to see today is, first I'll just give you a little bit of background so you know where I came from. Then I'll show you what I built. And then I'm going to blow up your minds or your ears. You never know. So you know when you go in a plane and you hear brace, brace, and they say, if you hear brace, brace, just cover your ears. So if you hear that, run, because it's like it's blowing up and it's going to damage your ears. So as you might have understood, I love music. And one of the first gifts I got when I was a child was a blue vinyl LP. And I think it was like something like this tall, and I just couldn't stop listening to that. It was like one of those horrible child bands. It was like, but I just couldn't stop listening. So I was like, can I listen to that again? And they were like, oh, it was a turntable. You couldn't just put it in a loop like an iTunes. You had to go put the needle back. So it was like this tall, and the turntable was here. So it was like trying to reach out. It was like my early challenge. And then the 80s were good times. So we had cheesy electropop, 8-bit video games, and Casio keyboards. Amazing. So this was mine. It was like 6-note polyphony, 6 or 8 instruments, and 0 frames. So it was like kind of limited. And for recording, you had to record to a tape, which wasn't ideal, but it was fine. And the 90s came. What that meant was multimedia, which was like, oh my God, CD-ROM players and stuff, and trackers. I don't know if you've heard about trackers. It's like a sample-based music program, so I could do lots of music. And I got into the demo scene as well, which is like graphics, beat, cubes, everything, all at the same time. And then VJing, which is like the same, but real time. And I got to go to live gigs, and I got someone to play some visuals while I was playing music, which was pretty exciting, but it's hard to coordinate with people, especially if your friends live in another country, like it was this case. So I got like introverted and got to software synthesis, and I started building my own synthesizers with C and C++. And I made virtual instruments, which is like a technology so you can have synthesizers with Cubase or any other kind of software. The problem with that is that it's hard to distribute because part of the SDK is proprietary, so you can't really distribute that. And instructions for building that are really confusing because you have to say, well, this part, you can use it, but then you have to go to Cubase, download something that I can distribute because it's closed source. So it was hard to get it to work for more people than me, even though some people distributed that in Linux distributions, which is pretty amazing. Like, it's so hard, but still people made the effort, so that was exciting. And then he's like, yeah, this is my time. And he got web audio. It's like, yes, WebGL, absolutely, and Node.js. I could be a one-woman orchestra. It's like, I don't need anyone else. I can do everything myself. So I wanted audio video output and hardware input. And I could glue everything with Node.js. So I got this thing. It's a QNU hardware controller, which is for hackers. It's got pressure-sensitive pads with LEDs. You can't really see that because it's really bright, but there are LEDs here. It's small. Oops. The nice thing is that it uses UDP. I don't know if you've heard about UDP, but it's like obviously you've heard about UDP. I mean, OSC, Open Sound Control. It's like a protocol you can use for connecting between different instruments and controllers and everything. It's like MIDI, but modern, like the big brother of MIDI. So this thing comes with something called OSC Bridge, which converts your USB data into something that any other internet-aware program like Node can digest. So with a nice module that someone already had made, I could just read whatever this thing sends me, and I can also send things to that. So for example, if I press here, it's just listening the touch events I'm sending, so I'm just getting messages here. And then I can also send messages here. So I can control the colors that you can really see again because it's very bright. And then that's for the input, but what do we do in the browser because we want to make it sound. So Socket.io, that's evident. And then the way this works is with OpenStack control, you kind of subscribe to addresses. It's like silence. It's like URLs, so you can match things with regular expressions like this thing. So for example, when I press a pad, I get sent a message with that structure, and I can say I'm interested only in pressing pads, so I'm just subscribing to that. I'm filtering everything else. And with Socket.io, I'm sending everything from UDP to this thing, to the browser, and just listen to whatever I'm interested in. And then I can also send messages. Again, you can't see that, but each path has like 4 LEDs, and I can control the red and the green values. So I can turn the whole thing red, whole thing green, or somewhere in between. And then that's for the path. Obviously, I had to do something that made sound. So previously, I used to build my whole thing, like totally ignoring web audio. I was just using the script nodes. I was like, everything, like, it was like if it was still C++. But then I thought I could do this with proper web audio, using all the APIs from web audio, and make it very modular. Like, I can include one thing, send the other, and reuse as much as possible. So the problem with that is that the very, very native web audio stuff is very, very native, and it's very, very limited. So you had to write lots of wrappers, and for example, the oscillators, whenever a voice just stops playing, it just disappears into the ether. So you need to make something so that you can detect, OK, this note has finished. You need to regenerate that. So you need to go making lots of little things like that. They are not very difficult, but they are not as intuitive. And they seem to be finding people by surprise a lot. And another thing that I think is interesting is I made a little envelope. I don't know if you know about envelopes. It's basically, if you got an instrument and you play it always in the same volume, it's boring. It's like, whoa, 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 whoa. You need to give a little of expression. So a way of doing that is having volume changes. So you can do that with envelopes. An envelope is basically attack, decay, sustain, release. So I built that, which kind of automates the way you can change parameters with web audio, which is something like set value at time, set parameter at time. You don't want to do that all the time, so you just automate that with a class. So that was for the basic things, but sometimes there were times that I didn't have enough things. Like, for example, I wanted to multiply the output of 2 nodes, but I don't think there's anything in web audio that does it, so you can just shame it with a custom node, which is pretty good. And obviously, you want to change things, so I made a GUI. And this is using, this is attached to whatever I created. So it's based on web components. I don't know if you heard about that thing. So if it's available, it's fine. If it's not, Extract will shame everything away, and just don't worry about that. So the way it works, I create instances of that, and then I attach them to real virtual instruments I created. Because as event-based, whatever I do in the GUI just reflects on the instrument. So I could be changing the release time, and it should be changing. So it's longer release or shorter. And if it changes that programmatically, it would change it as well, but I'm not going to live program here. So the first thing I wrote was the Bajotron, which is a funny game of words with Spanish and English. So it's like Basstron. And it's a more funny multi-voice and unisonic bass lane. So it means that it only plays one note. Multi-voice is because it's got more than one oscillator, and unisonic is because they are playing in different octaves, and it's a bass line. So this is that. And then it made the call tonator, which is like, it's like a padator, because call tone in Spanish is a pad. I just like to make funny names for things. So I started reusing things. So I just took instances of the previous instrument. I put them inside these things. So I've got like multi-polyphonic instrument just with the previous one. For this, I had to create what they call a voice allocation unit. So you can decide, OK, I've got 3 voices, and you're sending me 4 notes. So the first one is out. So you need to implement some sort of criteria for building this thing. And then I did pom, which is like a drum machine, because pom in Spanish is the way you kind of represent the sound of a drum, pom. So it's just playing samples. It's like an 808 or 909 or something, like this. And then reverb, I don't even know how to pronounce this. Reverbtron is an impulse-based reverb module, which I included that inside the cultinator because, what is this thing you can see here? Actually, the GUI for the reverbtron is inside the GUI for the other thing. Everything is inside. It's like the Matrix or Inception or something. So you can, I'm using web audio reverb things, so it's using samples for representing how the reverb should be behaving. I'm not sure it's seen very well. But basically, they go to a room, an empty room, and put some mics somewhere, and they record, and that's what that's what I'm using. That's how they record the way the sound reacts to different environments. So the nice thing is that whenever the new buffer is loaded, I just load it and draw it with Canvas. So it's pretty amazing. I'm just drawing an OGG file here. It's like, yeah, I love this thing. So yeah, just back to the other thing. And obviously, you need something, because otherwise I can't be a one-woman orchestra. So I made something to go with the music. And that's, of course, WebGL by three.js. And the thing is that I think this is something that many people find confusing. How do you render many times using only one renderer? It's very easy, actually. I'll explain later. And I'm not going to complicate it with the things because I'm not a 3D artist. I just made some cubes and stuff. They look kind of simple and minimal, so that should be fine. So yeah, the trick. It's a very simple trick. You create the render like this. You say, please don't delete whatever when you're done. And then don't auto-clear. And then when you render, you say render clear once, and then repeat render it for each scene you want to render. That should be done. You don't need anything else. That's it. And for playing live, obviously, you can't be doing everything at the same time. So I don't know if you heard about Renoise. Has anyone used Renoise or any tracker ever? No, I can't believe that. OK. So basically, Renoise is like a modern tracker. And it's like any other sequencer. You basically prepare a song with this thing. And it's a tracker. In the future, I would like to have my own web editor, but that would be like maybe 10 years' time when I have time enough for that. So in the meantime, I just made the song with another software. Like, I'm not reinventing this wheel this time. So the good thing about this editor is that the song format is XML. So, but I don't want to use XML, so I exported to JSON. And there wasn't any module for that, so I made an odd module for this. And the thing about tracker concepts that I really like way more than Reason or Cubase or anything is that it's got these concepts of patterns, tracks, and row. And some people say that it's like Excel, because it's like one page of data and it's numbers. That's how you sequence that. It's very hacker-like. So because it's like pages of things, and you just say, place this page in this order, and play this page again, and paste. So it's like very easy to know what's playing and when, and which row it is, and everything. So you can make very interesting things with that. So once you've got the order list, which is like this page, and this page, and this page, and this page, what I'm doing is I'm just creating a list of events so I can know what to do when I play live. And this is the kind of events I get, like note on, the note number, a timestamp, and then the order, pattern row. That's the thing that you can get from the trackers. And then instrument volume, that's obvious. So this is, obviously, you don't know what's playing. And why do you want to keep the order, the pattern, the row? Because imagine you're playing any sort of song, and you want to keep track of which bar you're in, so you can make interesting things with that. So that's why. And you need to sort by timestamp, ascending timestamp, because you need to schedule the audio events at precise times. So obviously, you're not going to be reordering the array all the time, because it's going to like melt your browser. So you want to make it like prepare as much as possible before you start doing the heavy thing. So you schedule everything at precise times, but the problem with web audio events is that you can't cancel them. So you can just prepare everything and send everything to the browser, because if you stop it or pause it, it's going to keep playing, and you don't want to do that. So what you need to do is request to audition frame. This is something I made up. Maybe it's not the best thing, but it kind of works. So what it does is periodically it goes and looks at the list of events and says, OK, so this buffer is this length. What can I fit in here? OK, so I'm just going to dispatch this, like play this node and stop this thing and launch this envelope and that kind of thing. But the problem is that sometimes it can be off. But you need to be aware of what's going on. I mean, most of the people don't really notice. But again, people don't even notice when pictures are pixelated and things like that. It might be just purists like me. But it's there. And how do you make the most of node data? So the tracker gives me these C4 things. And you can convert them to main node numbers. And then, because it's numbers, you can use maths, which is pretty always amazing with music. So, for example, with maths, you can say this node, for getting the high octave, you just add 12 to the number. So you can do these kind of funny things, like building chords or arpeggios, which is like, and it's all done with numbers. So you just use the node. OK, you can play things, but it's not the same thing. Yeah, why bother when there's the insert.js? Like, I could just hook this thing to the output, and that should be enough. But the problem is that, for example, if I've got a bass drum, like which is like, and then I've got a bass, and they both play in the same frequency, it's hard for the insert to say this is the drum or this is the bass. So they can't really tell. So that way, you can still have the FFT if you want, but you can also know what's actually playing and which node is it actually playing in. So that's why it's playing. Yeah, if you use the insert, you need to deal with thresholds, attack, decay times, and it's very different, and it can change from song to song, so it's not true for all the songs. So go jazz. Careful, be very careful. This is why I warn you. Like sometimes these clips, I hope it doesn't, but the first things I made, I was like adding many voices at the same time. It was like, I just had to take my headphones off. It was like killing my ears. So you need to be very, very aware of possibilities of clipping. So the solution for this is you have limiters and compressors as much as you can or as you need, so that nothing can go over 1 or -1. And the other problem is that it can break because it's changing. Web audio things changing a lot, especially, for example, with Nightly. Every day there are new things happening, changing, improving. Up until 2 days ago, this was leaking like heavily. You could close Chrome, you was still playing, and it was like, why is it playing? There's nothing here. I just closed the window, but the window was still there somewhere. I don't know where, but it was there. It didn't even show an activity monitor. I don't know, weird. But I guess it's part of the fun. We are here for having fun and breaking things and enjoying that, so, right? OK, good. So let's see if it breaks. Yeah, remember about this thing. It's working. It's not breaking. Stop it. Okay. Wow. I'm sorry. I think we're done, right? Yeah.
Awesome. Awesome. Can we get a round of applause? Awesome to have a presentation that is worthy of this set. I feel like I'm at Eurovision. Do we have any questions? You're gonna have to raise your hands. We have Angelina on mic back there, so even if you're back there, it's totally cool. Yes.
Hi. So you were playing like something with one hand and then changing the settings with the other hand, right? Would it be possible to connect some kind of controller so that you don't have to use your mouse?
Yeah, I just need time.
Okay.
So in theory, you've got this thing where you can have, I mean, this is like the whole point of the sliders, but
right.
I wanted to map it, like instead of pressing the mouse, I could map this thing, but time.
Cool. I thought that was very cool.
Yeah. Thank you.